Welcome to another video of my NIM for Beginners video series, Compile Time Function Execution, CTFE. In this video, I will teach you how to write code that will run at compile time, CTFE, and its limitations in NIM. The code for this video and its documentation script is in the links in the description as a form of offline tutorial. Compile Time Function Execution, CTFE, is a feature of NIM that allows procedures to be executed at compile time. This is a powerful feature that's relatively uncommon among programming languages. Restrictions on compile time execution. NIM code that will be executed at compile time cannot use the following language features: methods, closure iterators, the cast operator, reference pointer types, and FFI. The use of wrappers that use FFI and/or cast is also disallowed. Note that these wrappers include the ones in the standard library. Some or all of these restrictions are likely to be lifted over time as NIM improves. Constant variables and when statement refresher. In a previous video, I have covered both constant variables and the when statement. Let's quickly refresh our memories. To make a constant variable, we use the const keyword before the variable's name, followed by a value that must be known at compile time, like this. Const variable name is some value known at compile time, so a string will do. The value of constants also cannot be changed at any time, just like with variables made with the let keyword. Now a refresher on the when statement and some more in-depth information. A when statement is basically an if statement, except that it can only be used the reverse of an if statement at compile time only, while an if statement only at runtime. You can also only use constant variables and variables marked with the compile time pragma. Their value must be known at compile time. When statements do not open up a new scope, so variables made within them are accessible to the rest of the program, but only if the statement executes, because only the statement that is evaluated to true is compiled. Every other statement that isn't executed is not checked for semantics errors, only their conditions are. Here is an example of this. When false, and since this is false, it will not execute, and because it will not execute, this line in its body will not be checked for semantics errors, even though this is not a valid NIM code which would otherwise error. Also, each condition expression of a when statement must be a constant expression of type bool, so true and false. Controlling the definition of an object using when statement. When statements also enable conditional compilation techniques. It can be used with object definitions. I will now demonstrate an example of defining an object with one field or none, depending on the Boolean value of the when statement, true or false. First off, we will require a constant variable to control the object's definition. Const define is true. Now let's define our object. Also note that you cannot use a when statement to either define an object or not. You can only control its fields this way. So, type section, my object is object. Now let's use a when statement to either give our object a field or not. So when define, which is currently set to true, so when true, and since this is true, this one will execute. So when define data as string. Now instead of just making a new variable of type my object, we will instead use another when statement to control this as well. An if statement will not work for this. This will allow us to create a variable of type myObject with or without a field. If we don't use a when statement for making a variable of type myObject, then the moment we set our controller variable define to false, we will get an error trying to initialize a variable of type myObject with a field that doesn't exist. Also, if we used an if statement instead of a when statement, then our variable would only exist inside that if statement scope. Because again, if statements open up a new scope, while when statements do not. So, when statement, when define equals true, then we make our variable var my object is of type my object, and then its field data. Let's give it hello as string, and then let's also echo it, echo my object. Now an else statement for the false value, we're going to give it a bit later. Else var my object is my object, but this time empty parentheses. Also echo my object, and now also an echo outside to reinforce the point that when statements do not open up a new scope. Now let's run this. Here we go. Data as hello. The first one being the first echo from within the when statement, and then the second one from the outside. Now let's also rerun this with define set to false, so no field for our my object. F6, and here we go. Our object has no fields. When nimvm statement. Nimvm is a special symbol keyword that can be used in conjunction with a when statement. When nimvm is used to differentiate execution path between compile time and the executable. Executable being the program nim produces after compiling it, which when using F6 with the nim plugin in Visual Studio Code will run this executable, so runtime. Here is an example of this. First we have a proc with no arguments that returns bool. The first thing this proc will do is execute this when nimvm statement if this proc is being run at compile time, and then if it is, result will be set to true. Otherwise, this else statement will be taken at runtime at the executable, so then the result will be set to false. Then we have a constant variable of ct value, compile time value, that uses this proc to get its value at compile time. Then we have a let rt value, runtime value variable, that also uses this proc, which then gets its value at runtime executable. And lastly, we have two assert statements, which is an alternative way of debugging code. Assert simply takes some value, and if the condition is met, remains silent. Otherwise, the program will not run. To demonstrate this, let's run this. Okay, it remains silent, no problems. Now let's test this further by setting ct value to false instead and rerun this. Here we go, an error. Now, to demonstrate better when these branches get executed, let's add an echo proc to both the code that will run at compile time and the code that will run at runtime. Also set the ct value assert back to true, so that will remain silent, not give us an error. And now, first branch, echo, compile time. Let's copy this for runtime into the second branch, echo runtime. Now let's run this, F6. Here we go, runtime displayed at runtime, while the compile time is hidden in the output tab. Also, the default setting is the task, so we have to select nim. Here we go, compile time. Static statement expression. Static statement expression allows for forcing the code written in it to be ran at compile time. Even some code that has side effects being locations inside your program, such as variables, references, pointers, cstring, or other procs. Here is an example of forcing an if statement to execute at compile time. And we know that if statements are a runtime thing, and when statements are their compile time counterparts. Let's run this. Output tab, nim. Here we go, compile time. Now let's try this with a while loop and a var variable for the counter. So static block, in it we initialize a variable for the counter I, and then from 0 to 100, echo I, and increment for the repeat. Now let's run this. Output, here we go. Do you note that variable var I initialized in the static statement only works within that static statement. If it was made outside of the static statement, it wouldn't work at compile time, nor would it be accessible if it was made within another static statement. Let's demonstrate this with another example. So in this one, we declare the variable a is 10 inside, which will work just like above. Now if we move this initialization to outside of the block, it will not work. Cannot evaluate at compile time. So let's move it back in and demonstrate that using this variable from another static statement, it will not work. So another static, and now let's echo this a. Here we go, undeclared identifier a, because it was made in this static statement. Now a constant variable will work, but only if it was made within a static statement. So making it in here, this var into a const will not work. But if we put it outside, like this, const, it will work. So again, for a variable to work in a static statement, it must be made inside of it, or be a constant made outside of one. As you can see, static statement is very useful for compile time execution. It allows you to write just about any code, and it will execute at compile time. Though it doesn't make the when statement useless, because if you recall, a when statement can be used for object definition logic, while a static statement cannot. Also, don't forget about the compile time restrictions. Constants and constant expressions. Constant expressions are literals, built-in operators, previously declared constants, compile time variables, macros, templates, and previously declared procedures with no side effect, either tagged with the no side effects pragma and or none if proc iterator parameters do not contain in their parameters var, ref, ptr, cstring, or proc. In short, constant expressions are constants, variables made and used within a static statement, variables marked with compile time pragma, which are more flexible because they can be used outside of a static statement, followed by operators, macros, templates, and procs that can only possibly modify compile time variables. Now I will show you the difference between a static statement and a variable made with the compile time pragma. First, let's make a variable with inside a static statement and try to echo it inside and outside the static statement. So static statement for a is 10, echo this a, which will work, and then also outside, again like before in the previous chapter, echo a. Now this one won't work because it's made in the static statement, and static statement has this limitation. Now let's make a variable using the compile time pragma and try to echo it after it's made. So at runtime and then inside a static statement. So RB and then curly brackets, 2 dots, and inside that compile time. And now we give it a value, let's say 20. Now echo B, no errors so far, so if we F6, it will work. 20. Now inside a static statement, echo B, and run this again. Output tab, we go, 20. It works. Okay, that's it for this video. Thanks for watching. Like, share, and subscribe, as well as click the bell icon if you liked it. You can also follow me on Twitter of the same name and support me on Patreon. If you had any problems with any part of the video, let me know in the comment section. The code for this video is in the link in the description, as well as the link to this video's documentation script is a form of offline tutorial. Have fun.